complex number electric motor example 2, the motor has a resistance of 100 ohms and a reactance of 30 ohms. The total impedance of the motor is given by Z, which is the resistance, R in the real, and then J times the reactance. It says that we've connected this motor to a source providing 0.100 amps at 30 degrees and wants us to determine the voltage provided by the source. So the key thing that they left off of there was something we have to remember from the previous example, is that V is equal to I times Z. So if we want to be able to find V, we have to multiply I times Z. And then we know I is right here. It's 0.10 at 30 degrees, and that's in units of amps. Z is equal to the real part, which is 100 ohms, plus J times 30 ohms. Now again, the difficulty with that is this is in rectangular form, so it's not really good for multiplying and dividing. So what we need to do is change to polar form. So we get that Z is, let's come over here and do that, that the magnitude of Z is going to be the square root of 100 squared plus 30 squared. So the magnitude of Z is 104.4. The angle of Z is the tan inverse of the imaginary part over the real part. So the angle of Z is 16.7 degrees. So Z is really 104.4 at 16.7 degrees. And that's a resistance or an impedance, so it's in ohms. Alright, so if we use that, now we can take that V is equal to I, which is 0.100 at 30 degrees, times this quantity. So it is times 104.4 at 16.7 degrees. And the way we multiply quantities that are in polar form is we multiply the front coefficients so it's 100.100 times 104.4 at, and then we add the angle measures. So V is 10.44 at 46.7 degrees, and the units on that, it's V, so it's in volts. It doesn't ask us to, but we could also deconstruct that and put it back to rectangular form. I'm not going to show that equation. If you go back to rectangular, you should get that V is 7.16 plus 7.60 into J direction volts. But if you want to try to do that, I'll leave that for you to do on your own.